what's the minimum value of the following if x, y, z are greater than -1? I say, first of all, I notice that I can loosen y a little bit, simply because this inequality is true. Okay? That is because 1 minus 2y plus y squared is greater than 0. And of course, 1 minus y squared is greater than 0. Right? So I loosen y by half of 1 plus y squared. Likewise, zx. Right? So the whole original could be greater than 1 plus x squared over 1 plus z squared plus half of 1 plus y squared plus 1 plus y squared 1 plus x squared plus half of 1 plus z squared, then 1 plus z squared over 1 plus y squared plus half of 1 plus x squared. For the same reason. Now I just let half of 1 plus x squared equal a, and half of 1 plus y squared equal b, and half of 1 plus z squared equals c, right? For our own convenience. And so the whole thing becomes 2a over 2c plus b plus, it becomes 2b, 2a plus c. That's 2c, that's 2b plus a. Okay, so for this thing, so all I need to do is to apply Cauchy inequality, right, to this thing. First of all, I just rewrite it. Right, so first let's take out 2 first. I can rewrite it as the square root of a over 2c plus b, then squared. Likewise, square root of b over 2a plus c squared, then square root of c over 2b plus a. And then multiply by another sum of squares. Right? So I say square root of a times 2c plus b, 2c plus b squared. Then square root of b times 2a plus c squared. Then square root of c times 2b plus a squared. Right? It's greater than. First of all, you have 2 groups of numbers. This group, this group. Then you have square each number, then you sum them up. Square each number, sum them up. Then you just multiply the corresponding number. Right? Then square. Right? The product of this number and this number. Right? 2c plus b cancel out. Square root of a times a, that's a. Likewise. Right? So this is what we have. And of course, later we'll discuss when equality holds. Right? So this divided by this equal to this, divided by this equal to this, divided by this. But for now, I just say, if that's the case, I can say this must be greater than what? Right? Because remember, this is essentially that. This is rewritten. So maybe I just divide this over here. Like this multiplied by this, so I divide this over here. Right, so the top is just still a plus b plus c squared. The bottom now, I have this whole thing. Right, that's A times 2C plus B plus B times 2A plus C. C times 2B plus A. So from here on, I just simply expand it. Right? So quickly, it's just okay. Maybe let's write here. Okay, here we have, right? So twice of here, just A squared plus B squared plus C squared plus 2AB plus 2BC plus 2CA. This is a standard expansion of A plus B plus C squared. Then we have AB, 2AB, 3AB. Likewise, 3BC, 3CA. This is just quick expansion. So here, I got twice of A squared, B squared, C squared. Then I say, okay, A squared plus B squared. Then B squared plus C squared. Then C squared plus A squared. I got twice of each square. Then I say I can just minus 2AB and minus 2BC minus 2CA. So after that, remember, here we have 2 times 2AB, 2BC, 2CA. We got 4 times each. Right? But here I have negative of each. So I must say plus 6. Right? Then 6 minus equal 4. Right? That's 4. So I must say 6 times AB plus BC plus CA. So down here, 3 AB plus BC plus CA. So right now I just simply have a perfect squares. B minus C. C minus A squared. 6 AB BC CA. 3 AB BC CA. Right? Since this is of course non-negative, right? So just get rid of them. It's no larger than this over that. It's simply 2. Right? So of course the minimum value is just 2. It's when this term equals 0, this term equals 0, this term equals 0. So it's when A equals B, B equals C. So given that A equal to half of 1 plus x squared, and also given that for our equality to hold, not only we need A equal B equals C, we also need, remember, initially I say I use this inequality. Right? Of course, for equality to hold, I need this equality to hold as well. Right? So I require y equal to 1. Likewise, x equal to 1 as well. Z equal to 1 as well. Right? The reason is because not only this inequality, but I also apply to z and x as well. Right? And so which tells us that if that's the case, I have x becomes 1, I have 1 plus 1, so A equal to 1, B equal to 1, C equal to 1. And not only that, we also have to make sure that during the process when we apply the Cauchy inequality, which I erased, and we also have to make sure it's also compatible, also consistent, right? So whatever, I just rewritten this into whatever. So you have to make sure that you have two groups of numbers, and the corresponding number, their ratio has to be the same for each pair. Right? It turns out it's also compatible.